We good? I think we're good. Hey guys, I'm Hedgeberg. Thank you for the patience. I am here now. It is Tuesday, September 5th, and we're going to be working on some more Switch reverse engineering work. So let me go ahead and get us started. I'm going to need a few moments here to go ahead and pull up main monitor, check to make sure that my video capture is working. It is not. Don't finally me. You're right here. You could see what I was doing.
That's not what I was finaling about.
Okay. Hey, Mark G Plays. Also, honey, thank you for the bits. Okay, let's see.
They finally let me get goddamn bits again.
Finally. Okay, let's put that down
there.
there. Okay, what am I,
Sucker.
Right, that's what I'm doing. Okay, there's that. Audio is good. Hey, Real Cloud, welcome to the stream. Anything else I am supposed to be doing here? Don't believe so. Oh, wait, GUVCV, that's right. There we go. Sorry, guys, just get my microscope plugged in because I moved some stuff around. Okay, let's see. I can't give an official endorsement to 100% Orange Juice. They haven't paid me money. Now, if they paid me money, then I could think about endorsing them. Okay, there we go. Also, for those of you who weren't here, we played 100% Orange Juice right before the stream. It was a lot of fun. You guys should consider joining us for next time. Anyway, we are good to get started, so let's get to it. Let's go ahead and take a look at what we've got thus far. So, let's begin. Most of the stuff you're going to want to be paying attention to here is hardware cam. Let me zoom out on the microscope, though. So, you guys may have seen it on Twitter, but the setup has been modified to include this little guy right here. This is the Chip Whisperer breakout board. I meant to have this last stream, and instead we wound up substituting for my FPGA, but this is the basic idea. It's just a breakout board. It's a pretty simple concept. So you've got a ribbon cable header in the middle there. Let me also go ahead and move this over so you guys can see more of what we're dealing with. So it's basically just the header here, plus some LEDs, plus an IO LED you can use for human-computer interaction. But what I did was I modified it to add these coax ports. So this is what it looks like on the underside. It's basically just a simple thing with I scratched some points in the ground plane for attaching, and then added some hot glue just to keep things structurally sound. So I'm just attaching to the high-speed I/O pins. I can zoom that a little, or I can focus that a little bit better, can't I? Yeah, there we go. So yeah, I'm just looking at the high-speed I/O pins specifically, but the rest of this is basically unmodified. So this gives me the ability to actually tap out the high-speed I/O from here. And the high-speed I/O is specifically used for clocking remote targets. So what that allows us to do then is actually go ahead and plug that into the switch where FPGA was last time. So that looks like this. And then once we add that and we do this, the Chip Whisperer is actually coupled into our setup, and it's that simple. And so that was the main goal there, was getting that set up so that we could have it all looking pretty nice. So let me go ahead and take a second to show you guys where we're at, because we've got underclocking working on this guy. So I can show you guys what it looks like with the default frequency of 38.4 megahertz, since the Chip Whisperer can actually drive that, unlike my my regular FPGA, which I do not have a good PLL setup on. So let's show you guys what that looks like. Boop. Okay. So let's go ahead and quickly review the parts of our setup. So we've got the microscope right here, so you guys can see my fingers right here. And in addition, we have our switch, which I have modified to add a coaxial port, or an SMA coaxial port, I should say, specifically. And that is being used for adding external clock routes. So we mounted that on top of the CPU shield using the copper tape to get solder, and then when that didn't hold up, I had to add some glue. And actually, the copper tape got pulled away by some isopropyl that we put under there by mistake. So what we did was went ahead and soldered a wire from here down to the grommet hole down here. And so now that gives us a clean connection from here down to there. And then what we did was we went ahead and made another modification which is using the, well, not a modification of the board so much as we added our EMMC sniffer. So that's out of order because the EMMC sniffer was already in last time. You guys saw that. But that being said, and sorry about my thumb. I chewed on my thumb too much. Okay, so this is actually adding a bit more pressure than I'm comfortable with. So I'm actually going to take a...
Someone's asking about your username.
On what?
On stream.
What does your name mean? Hedgeberg. Hedge and iceberg? Iceberg lettuce? I don't know. I leave that up to the viewer. It's a nickname that I came up with a long time ago. I'm not going to tell my secrets. It does mean something, and has something to do with me personally, and that's all I'm going to say. Leave it as an augmented reality game, if you will.
It's like an iceberg made out of...
hedges,
That's just like a real big tree, dude.
but in the middle of the ocean. It's an ocean tree. So I'm just adding some test clips over here so that I can actually show you guys this, because there's been a lot of mechanical tension on here, which is making it harder for me to see this. So I'm putting that there. We may actually end up working, among other things, on modifying the sniffer board today. So if you guys are interested in seeing some printed circuit board design, we'll be working on that. It's pretty simple. It's a really, really good basic example of what printed circuit board design is like, actually. So that may be worth doing at some point. So we've got our EMMC sniffer board, which is this guy right here. The EMMC itself slips in right there. Where did I put that? Here we go. So this goes right here. Okay. We have our pins connected correctly, I believe. Oh, there we go. Oops. Okay, there we go. I'm going to go ahead and actually get the microscope out of the way and just focus mostly on full screen hardware cam, though. Where is that? Let me go ahead and actually turn off studio mode. Let's see. There we go. So let's go ahead and full screen that for now. Yeah. Actually, I should probably move this over this way a little bit more. There we go. That's a better view. So, BPAF. That's the hope. I don't know how long it's going to take, but that is the end goal. There's some specific stuff in the bootloader, which is interesting
Backpack
looking.
as fuck?
Huh?
Backpack as fuck.
Backpack as fuck? What?
BPAF.
What does B... Oh. Okay, yeah. No, I do not... Okay, I'm not going to comment on as to whether or not I have a fetish for iceberg lettuce. But I will say, love me some iceberg. Whether or not it makes me sexually aroused, no comment. Go ahead and move this down here. Okay, so we are set up to go ahead and actually demo the underclocking real quick. So let's do that. Let's go ahead and get Logic open. Wait, 3.02 is out? Wait, what? I did not even know. I did not know that 3.02 had happened. I am just hearing about this myself. Let's resize that now. RIP. We don't actually know what's going to be on there. No way to know. But I mean, again, we don't really recommend being on anything above 3.0. At this point, the most important damage has been done. We've lost SM, so past that, any updates are not recommended. But it probably doesn't matter that much. But I'm not going to say. It means that they patch something, and if they patch something, it's going to be something important. Okay, sudo document / logic. No, Black Icer, it's not downclocked. They overclock the switch in the dock. They do the opposite. They actually up the clock speed in the dock. Yeah, it is. I mean, the Switch gets really hot because of the fact that it's trying to deal with higher resolution stuff. Okay, 500 megasamples per second should be good. So let's... Wait, we don't need to go 500 megasamples per second. We can actually take it down to 100. No, we should stay at 500. So we have to go ahead and actually set up the clock first. Let's go ahead and open up Chip Whisperer. Is it set up here? No, I have to launch it from terminal. Control T, Chip Whisperer, cap, ampersand... Spins it up in the background. Okay, so we go to Scope Module, Chip Whisperer, connect. There we go, got those nice blinking lights. And I have to go ahead and configure our clock information. So we come on down here to the clock gen section. So we're going to want to go ahead and show what it looks like at the default 34.8 megahertz. Nope. 4.8 megahertz. What on earth? 30 megahertz. There we go. Why was it being so weird about it? Sure, we'll leave it at 34 megahertz. Perfect. Okay, now we go ahead and set U, reset. Cool, perfect. And that gets rid of all of our bad lights, and we are all set. To reset the ADC clock module after that, but that should all be good. Now the thing that we need to do is actually go ahead and output our clock frequency. So we do that via clock gen, and that should output. Okay, there we go. Let's go ahead and get to it. So if I go ahead and pull this up and I hit start. Wait, need to plug in the battery first. We should be outputting enough of a signal that we can actually get this to boot as desired. Yep, and that goes almost immediately. Check that out. And it does it all in under half a second. So this is all of the data that's needed to get the Switch booting. After that, it fails because of the fact that it can't actually get any more eMMC reads. The data speeds are too low, and I think package 2 corrupts, resulting in a panic loop. And that's because of the fact that there's too much reflections, and there's not really anything we can do about that. But it doesn't really matter because we can demonstrate how fast stuff moves. So what you can see here is in under 0.4 seconds, the Switch has read the BCT. So there's the process of taking the NAND live, reading the register configs and the BCT data. And then it reads package 1 over here. And then over here it reads package 2. And then past that it can't do anything. And it looks like package 2 probably doesn't read correctly anyway. Like, you see all these impulses. That's bad. So package 1 and 2 probably do not read correctly. But that does not matter because we can see what's happening. So now what I can do is actually take this down to our minimum frequency that we're able to actually pass out on the Chip Whisperer, and that's 3.3 megahertz. There we go. Now that we've done that, let's go ahead and show you guys what we're looking at. So if I go ahead and plug in the battery, and I go ahead and press start, and I press that button. Okay, nope, it's freaking out. Oh, right, I have to disconnect it. There's something weird going on with this system that causes some resonance that shouldn't occur. So I sometimes need to stop and restart stuff. So cancel. There we go. Okay, there we go. Plug this in. Start and power. And you can see how much slower this is going already. If I hit stop, there we go. A perfect multiple of 10. We have slowed down the Switch by an order of magnitude, giving us not only very clean data reads, but huge gaps of time in here. You can see the amount of time that it takes for it to do just these basic reads. And that's huge. if anything, that's extremely significant. It's also worth noting that there was a command loop here during this section to see how long it took for the NAND to go live, and it was getting no responses for a while here. When we underclock it, it actually gets a response on the first round. That's kind of neat. So we've actually gone ahead and pulled the frequency down far enough that we can take advantage of it pretty heavily. So that's something that will be coming into play later when we finally get whatever we do in terms of a write-up done. That will probably feature pretty heavily. But yeah, that's where we're at right now. So this is the first of many things that we need to do to actually set up for glitching. And this is in basically any system. What's going on here? Oh, Type-C. USB-C spec is not a mess. It's that companies are not putting in the money to properly... companies aren't putting in the money to actually do things smart. And Type-C doesn't... Type-C is just a connector. There's a lot of different stuff that falls into the specs that are applicable through Type-C. So USB Type-C is a connector, and then there's a lot of different variables in the spec. So, yeah, we should be good to go ahead and move on now. So the next part of this will actually be flipping the board and taking a look at what we can and can't remove. So this is the way our setup looks right now, and it's pretty effective, actually, for getting our underclock. So, chip whisperer, breakout board to SMA cable loops around, plugs in to replace the switch, and the switch and the chip whisperer will only be becoming more and more connected from here on. This is just the start. As we go, there's going to be a lot of connections formed, really all over the place. These are going to become very intertwined systems. So, yeah, we did get it working, Savarik. It only took a little bit of time after the stream, actually, for me to get it playing nice. And once I did, we were good. And then I just had to go ahead and swap in the Chip Whisperer program. Or we just had to go ahead and switch in the Chip Whisperer. Yeah, Sele's logic software is pretty decent. I mean, I know that SIGROC's a lot better, but I'm a big fan. Anyway, that's getting us started. So we need to go ahead and start talking about how we modify the voltage rail. No fair. No fair. Okay. Yeah. Cool. Also, if audio stuff gets wonky, by the way, I was messing around with trying to get Jack set up, and to try to get Jack started, I tried suspending Pulse Audio, and now Pulse Audio doesn't launch by default whenever I turn on my computer. And there's just a lot of weird stuff going on. I think Jack might actually be running in the background right now. There's a lot of weird problems going on there. But that is, if that becomes an issue, I'm really sorry. Let me know. So, where do we go from here? We go into modifying the voltage rail. So there's a process for this. So we're actually going to go ahead and use my old images that we stitched together for the switch. So this is where our prior research comes in, and this is why we were doing the prior research. So we're going to go ahead and get into that, and then we'll flip the board, and we'll take a look at our... Actually, we should go ahead and flip the board first, shouldn't we? Yeah, probably. Okay, let's go ahead and grab that. Yep, I know. Error in the scope. So let's go ahead and move the chip whisper out of the way for now. Let's go ahead and minimize these. And let's get the goddamn JTAG adapter unplugged, because that really doesn't need to be here. And I should actually go ahead and get my solid-state drive real quick before we do anything else, if I'm being totally honest, because we're going to want to go ahead and be able to look at our switch images as reference. So let me do that. And let me also unscrew this SMA cable. One of the issues with the way that I got this in, there's not a lot of clearance, and it means there's a lot of friction when trying to plug in the SMA cable, which makes things a little bit painful. But, yeah. So, let me free that. Takes me a long-ass time to get this unscrewed or screwed back in. So, let's just take that off camera real quick. Here we go. Come on. Slow as hell. Yeah, it's annoying as hell. Sorry, guys. Need a second here. I know it's probably frustrating to a few of you. One of the things, actually, is we probably don't need to plug this in anymore, since at this point, the NAND reads are done before the screen turns on. And past that, we're not really interested in anything else that comes up. So we can probably actually get rid of the rest of the enclosure. So it might be a better idea for us to actually have the motherboard free from now on. So that's something to think about. Anyway, we'll be working on getting this out in just a second. Anything else I want to grab before we start? Nah, we should be good. So, yeah, I guess, you know what, we're starting it. Let's go ahead and just get our shit out. So, pill bottle for my screws, because I keep almost forgetting that, and that's going to end badly one of these days. Have somewhere to put your screws. It's a good idea. Don't lose screws. It's a nightmare waiting to happen. So, let's grab that. Cool. I'm just down here removing the head plate for the headphone adapter. Okay.
Can you pass my chapstick?
Yeah, where is it?
It's up there.
I don't see it.
No, it's near the mouse.
Oh, yep.
Thank you.
Mm-hmm. Okay, so starting off, come on down here for the ribbon cable. Oh, come on. Oh, man. Warping my tweezers more than I'd like to admit. There we go. Just use your nails sometimes. Okay, get out the header there. That pops out. Okay, oh, I should go ahead and hit escape on there. Oh! Did that kill... that did kill GUVC view. Weird. I've never had that happen before. Benson Nathan spreadsheets were a... has been testing cables and created... Oh, yeah, yeah. Yeah. I'm glad that some people did that. Those were guys at Google, if I recall correctly. Partly because of the fact that Google was instrumental in setting up the USB-C spec. I think a few groups agreed on USB-C before it actually was taken to ISO. ISO, if I recall correctly, is the International Standards Organization. But they are responsible for this kind of stuff. Come on. Man, I cannot get good depth perception on this microscope. There we go. Okay. Let's get this. Cool. I need a new set of tweezers at some point. One day I'll have money for all of these things that I want. The poor tweezers are getting deformed. There we go. Next one. Okay, we should get the screws now. Wait, let's get out the Joy-Con adapter. I did not mean to still have the battery in. Hopefully that won't come back to bite me in the ass. Okay. Yeah, no, Scanline does this, and she's far better than I am. She's really just the best. She started showing up here too occasionally, which is a huge honor. Like, it's kind of crazy that, you know, I can start doing this stuff and then have people who I look up to in the security or tech circles that I follow show up to see what I'm up to in these streams. That's nuts to me. Kind of cool. Anyway, yeah, if you're interested in this kind of stuff, Scanlime is A+. Live Overflow has some really cool tutorials on stuff like Pegasus that you can definitely take a look at. Oh yeah, Louis Rossman's great. I'm not a huge fan of his soldering methods because he just like globs shit on, but he gets the job done. It's kind of like industrial style soldering, and he has the tools and the skills to back it up, so it works. He's also a bit of an abrasive person, but like when you're that skilled, I feel like you're allowed to be a bit abrasive. Because his whole thing is repairing computers that people fucked up and then lie to him about, basically. There we go. Yeah, New York style, exactly. That's a good way to put it. Rossman's great, honestly. I should watch more of his stuff. There we go. Okay, motherboard is freed. So, yeah. But, I mean, a lot of my techniques I take from the... So here's the thing is, I don't ever watch technical videos all the way through. It's kind of a problem. So a lot of my stuff, though, is stuff that I've taken from stills of Scanline, because I'll see a still of the way she works and think, oh, that's awesome. It's just that I really should have, like, Scanline vids or something in the background while I work at work more often, but I don't. I don't know why. I need to work on that. Like, the stuff that I listen to in the background is usually just podcasts, and honestly, I feel like that's starting to get to the limit of what I can do. So yeah, here's the way that the board looks right now. Pretty basic. Here's our ground connector that I added. Here's our attachment to the clock pad down there. Yeah, cool. Wireless SoC, the Tegra SoC and RAM are under here. Screen connector. Yeah. Okay, no point in dabbling with that. Let's go ahead and get to it. So, most of what we're doing today is going to be on the back of the board, specifically in this area. Basically, what we're going to be looking for is a way to actually isolate the main supply rail. So let me go ahead and actually get this. Will this even fit in the stick vise with the coax adapter in there? I'm not totally sure. Let's find out. One day we will get to California. One day. Okay, there we go. So, okay. So on the 3DS, we happen to have the benefit of these really neat EMI filtering capacitors. Actually, I see one right now. This guy. And so the way an EMI filtering capacitor works is that the capacitor actually is shorted along... So the idea is it's actually not a capacitor in the sense that you'd think of. So it's actually shorted from here to here. So if I were to take a multimeter and do continuity test from here to here, it would actually show positive. And then these are actually wrapped along the base. So the idea is that actually what's happening is you've attached this to the ground plane and the power channel along here, so that the power plane is tightly coupled and basically running very closely to the ground plane. So this is to allow you to actually filter electromagnetic interference between the supply chip and the target source. So this is to actually strip out any noise that could be an issue. So specifically to remove exactly what we're trying to do. But the benefit is that all of the power is being routed through one of these. So if we can find the right EMI filtering capacitor and remove it, that gives us exactly what we need in terms of powering the SoC. So that might be perfect. So what we'll want to do is we'll want to actually remove this. We'll probably put a resistor from here to here, which will isolate the chip from the power management circuit, and the result will be that the chip becomes susceptible to other sources of interference, and that's where we're going to generate our glitch. So if I were actually, you know what, I could probably get the tablet and take a few seconds to draw up the way that this works, and what the Chip Whisperer style of glitching is. Yeah. Xenofex. That name does sound really familiar. One second. I'm sorry. I'm going to look up your name because that sounds really familiar. Xenofex. No, I don't think that's Xenofex. Why does that name sound so familiar? Are you somebody that I feel like I should know? Maybe I know too many people with names ending in... Oh. Oh, shit. I know exactly who you are. I'm sorry. No, yeah. You say that, but I think your stuff's cool. I have a tendency to check every single person, the profile of every single person who follows me. So, I'm a creepy person. Anyway, so I need to go ahead and probably it's going to be this EMI capacitor. If it's not though, then it'll be located somewhere else on the board. It's just a question of where. So on the 3DS, we actually had the benefit of having one of these right near the SoC. I don't actually know if this is going to be the one that we want or not, though. So in a moment, I will go ahead and get a board so that we can talk about the reason why we want to be doing this, because I think that's probably a pretty good thing to have if you want to understand this. Motivation for this kind of stuff is pretty important before we get into it. I just feel like there's something I'm forgetting about, and I don't know why. Nah. Okay, give me 1 second, guys, and I'm going to actually go get the tablet so that I can demonstrate what exactly we're doing here. Let's see. Honey, where's the tablet and the tablet pen?
What?
Jesus, where's the tablet and the tablet pen?
What?
Where's the tablet and the tablet pen?
On the cat tree.
Okay, thank you. I'll be right back, guys. No, you didn't miss much at all. Give me 1 second, guys. I'll be right back. Hey guys, I'm back. Let's go ahead and take this into main monitor. And where did I just put the tablet pen? There it is. Okay, cool. It is covered in cat hair because it fell behind the cat tree, which our cat doesn't actually use for anything other than the scratching post. But we love the little shithead. We really do. Okay, this is inverted. Okay, let's see what we got here. Okay, perfect. So let's go ahead and bring up GIMP. I'm actually going to go ahead and sit down for this. Need a moment here. Okay, yeah, I want to be sitting down while I'm drawing. So, what we're going to look at is what exactly needs to happen for this style of glitching.
Don't yell.
What'd I do?
You yelled.
When?
Just now.
There we go. Okay, hopefully you guys can still hear me. I'm actually going to go ahead and put on some music in a second since nobody's here to talk to me. Gonna need that if I don't. I'm gonna need that to focus in just a moment, or else I'm going to lose my mind. Actually, Wolf Mitchell, if you're in the stream, any chance the server's back up? If not, no worries. Okay, move that. Okay, cool. So, let's take a look. So, if I go ahead and pull up GIMP. So, cool. File, new. Let's go ahead and make it full screen. Hey, Esden. Thanks. Yeah, I just found out that she did that. It's really nice of her to do that. Like, it's so sweet of her, really. She really doesn't need to do that, and it's so nice of her to do that. Nope, I don't need that. Where is my... Every time I get screwed up by this. Okay, I need... don't need selection editor. What was it? Tool presets. No, damn it. I'm doing it again. I'm back on my bullshit. Nope. I don't think I need layers, though. Oh, tool options. God damn it. Okay, perfect. Cool, let's take the size down to 1, and let's get to it. So here's the way that fault injection works, basically, on the most fundamental level for this specific setup. So the way that I tried to... This is actually one of the things that I screwed up when I was trying to get my fault injection system set up, is that I was trying to actually go about it in a way that really probably wasn't the smartest. So when I tried to actually go ahead and... before the final revision of our... before my final revision of the boot ROM attack, the way that our system actually looked was a PMOS and an NMOS, and if you guys are seeing this, this should look very familiar. If you guys know electronics, this should look very familiar to you. Actually, that's not a... This is actually a negative rail. So we had plus VDD. Oh, Jesus. My handwriting... Every time I come back to using a tablet, my handwriting needs to take a second to recalibrate. But so yeah, this is an inverter. The reason for this, though, it will become obvious in a second. What we actually had was we had a DAC. And we had an op-amp. And the op-amp looked something like this. Boop. So here's our negative, and here's our positive. And I've taken a few times to explain negative feedback. But the basic idea is that the op-amp is responsible for trying to make V plus and V minus approach each other. So ideally, V plus equals V minus in the case of a high gain op-amp. So, Tux, this is with a tablet. Like, this is with a tablet. I have really unsteady hands. I have really, really unsteady hands. I don't think you understand what I mean when I say I have unsteady hands. I mean my hands shake. Like, if I try to hold my hands steady, they shake. They vibrate. It's not good. Yeah, I did hear that Switch to V3.02 came out. I have no idea what's going on with it. So, basically, this was the idea, was that the DAC would allow us to... Oh, almost certainly way too much coffee. My coffee habits are awful. So what we would do is we would have an 8-bit bus here. And so this would actually allow us to go ahead and select levels on the DAC. And then the DAC would provide us a voltage, and then the voltage would be mirrored at the negative value. But the idea was that this... we could draw huge amounts of current down or up. So we would have a very, very large eye. So this was the idea, was to have this is an inverting CMOS output buffer. Oh, you guys can't see that because of the hardware cam. Let me go ahead and shrink that. So inverting CMOS output buffer. And the idea was to actually go ahead and allow us to get a way to bias huge amounts of power. So what we would do is actually go ahead and... So we'd actually go ahead and put our target right here as well. Ground. And so the thing is that this would actually allow for us to direct all of like 4 amps towards the SoC. But the thing is that this has to be constantly saturated, which means that there's always current being drawn from plus VDD to minus VDD. So like always had to be like 4 amps through here at all times. And it was just a question of how much was being redirected over in this direction. So the issue is, there were a lot of issues with this setup, one of which being that it was a huge problem to stabilize. Just a huge, huge problem to stabilize, and it was becoming a really, really major problem. There were a lot of problems with the setup, frankly, and I kind of hate to admit that it probably wasn't my best work as a circuit designer. I think it could be made to work, but you need to actually solve the initialization problem. But the way that Chip Whisperer does fault injection is way simpler. And honestly, I feel stupid for not using it initially. I have a problem with over-designing. Classic engineering problem. The way the Chip Whisperer works is really simple. The idea is that if you usually have an SoC that looks like this, so power, ground, so VDD, GND, and you got I. So the thing is that what you can actually do in order to inject a fault in a system like this is to go ahead and do the following. What you do here is you actually insert a resistor. Usually a small resistor, but still a resistor. And the idea of the resistor is that this actually isolates the SoC from VDD. This means that usually the SoC will be at the value here, we'll call this Vx. Usually Vx is about VDD. But you also have a really big high slew NMOS right here. And this NMOS is attached to the Chip Whisperer. And the idea is that when we want to actually change this, the Chip Whisperer turns on this really, really big MOSFET, and for the time that the MOSFET is on or turning on, it's siphoning charge out of this node. And that actually happens even before the MOSFET is all the way turned on. NXDev, Strong is looking for the milk of human kindness. Show Strong the milk of human kindness. Stupid. I've never actually played that game. Just watched Northern Lion play it. I should go back and do that at some point. I have it. I just haven't played it. Anyway, so the idea that MOSFETs actually have some pretty interesting charge properties, one of which being that there will actually be a pretty large field buildup right here as soon as a voltage is applied here. So even before this is turned all the way on, it's pulling charge out of this node. So this is actually a really decent way to set this up, and all of the power from here will be dissipated into the ground for as long as the MOSFET is turned on, and that can actually be enough to actually blow it out, because VDD can actually, like if this resistor is small enough, so for R equals 0, this is just a short, and that means that VDD and the ground are fighting, and so you'll pull it down to about 50%, but you'll also be doing a lot of shorting. With R is equal to, 1 ohm or something, there's actually something to dissipate across here, things like that. Oh, God. Y'all are the nastiest.
You're the one who said milk was pulpy.
It's a suspension.
It's not.
Look up
pulpy.
a suspension.
Pulpy. Stop.
I'm just saying, milk is a Drink some more coffee. Okay, so this is the idea. So the idea is that we're going to want to actually replicate this setup. There's one other thing, though, that we're going to need to modify, which is that usually an SoC has huge amounts of capacitance built around it to insulate it from exactly this kind of behavior. So among other things, in addition to adding this resistor, we are actually going to want to remove all of the capacitors around it. So that means that all of the... Sorry, guys. That means that all of the capacitors that are on this line need to go if we're going to execute this effectively. So that's the idea for this part, is to actually go ahead and find a point where we can isolate the rail. Whether that involves slashing a rail or something else will remain to be seen. In an ideal world, it'll just be removing one of those EMI capacitors and replacing it with a resistor. And we can go ahead and remove this. No, I can't reduce my coffee consumption. I always need more coffee. Quantity of stuff on desk has no effect on that. So this is the basic idea. I know that my drawings aren't too good, and I'm sorry about that. But I figured it was a lot easier to explain if I could actually go ahead and show some circuitry. So that's the basic idea. Okay. Let me go ahead and get my hard drive, and we'll go ahead and take a look at what we're dealing with in just a second. Hard drive's over here in the backpack, along with the adapter and my cable. What are you talking to folks about in chat? Other than discussing milk?
What?
What are you talking to folks about in chat?
Milk.
Milk.
You have milk chat now.
Milk chat. Say no to milk chat. Say yes to milk chat. Say milk chat. There we go. And then I do that. And then I do that. I already did.
Listen, I have headphones on.
Okay. Coffee is like a drug, and I do drink too much of it in one day. I am actually almost certainly at a point where I can undergo caffeine withdrawal. I think I have multiple times, honestly. It's not good. Let's go ahead and grab side A. Where's the stitched image? No, this is the one that we didn't finish stitching. Where's the one that we did finish stitching? Sanding. Okay, cool. The sanded board is better anyway. Where's the stitched image? Nope. Detected. Where is it? There we go. What the fuck? No, that's definitely a PNG file. Like, that opens fine. Oh, no. I better have given these to somebody, or if these are corrupted, I'm not going to have a good time. I might have to redo the stitching. Okay, let's open up Hugin and do it again. Fuck me. Is this even the right side? Let's see. Yeah, it is. Okay, cool. Give me 1 second, and I'm going to go ahead and open this up, and we're going to do this shit. I'm sorry. Yeah, the preview works, but the image is corrupted. Good news is we can just repeat it with Hugin, because we've got the project file saved. Probably won't come out as nice, but hey, it is what it is. So let's see. Here's Hugin. You guys get a chance to see what my project looked like. Switch RE, side A, sanding. There we go. Let's do interface. Expert, perfect. Let's see. Let's do the fast preview. Yep, cool. There we go. There's that and that. Okay, that looks pretty clean. Let's just go ahead and export. Okay, crop, all fine. Okay, the only issue that we need to remember is... Okay, let's see, that all looks fine. So we want exposure fuse from any arrangement. We also want the high dynamic range option. Exposure corrected low dynamic range. Let's see. Don't need that, actually. Combined stacks. Blended layers of similar exposure without... Nope, don't want that. HDR merger, blender, built-in options. Blend seam. Oh, it even saved that. Cool. Built-in. Do you have Nona or built-in? Yep, infuse. Cool. One of these has a couple. Yeah, okay, cool. That should be good. Stitch. This will probably take us a few moments. Sorry about this, guys. Pain in my ass, but hey, it is what it is. Yep. I mean, the image is on the original. The image is uploaded to Twitter, but it's not going to be. It's going to be compressed, unless there's something that I don't know about. But this was like a 35 megabyte image, so I kind of doubt that Twitter would have the whole thing. Man, oh, you know what? We don't need the HDR stuff. What am I doing? I should cancel this. Okay, cool. It did cancel. Okay, we do not need the high dynamic range stuff. Exposure fused from any arrangement. Okay. The high dynamic range stuff takes way too long. Yes. Why is this going so slow? Weird. Hey, if anybody can figure out how to get my, if anybody can figure out how to get those original images off of my Twitter, then by all means. I think we also have them uploaded somewhere on Reswitched. I don't know, though. Let me see. I might have to go into the private section. Okay. I love this app's optimism. Stitch. Oh. Stop. Stop. Okay, so this is all confused. Hugin's just having a shitty time. 1 second, I need to... There we go. Okay, cool. Now I can actually go ahead and try this again. Save. Okay, now it's actually... Is that going to play nice now? Doesn't look like it. I have a feeling that, I have a feeling this isn't going to play nice. Let me see if I can do that. Let's go ahead and home. I'll see if I can't find the actual file on Twitter. That's weird that the file got corrupted. I wonder if it was when I was dealing with some of that weird... I wonder if it's an issue with the NTFS journal, actually. You know what? I bet you that's also why this isn't playing nice. My NTFS is probably fucked up on... It's probably fucked up on this. I'll probably have to run fdisk on it. Okay, let's see if Twitter has my original. Come on. Shitty memes, supercard. Going way, way back. I can't believe that it's been this long since I did the board sanding stuff. Kind of crazy. There we go. Colon, oh! Colon large, colon ridge. Yup, there we go. That is a big goddamn file. Save image as. Save. I probably had to convert it to a JPEG just to get Twitter to accept it. Yeah, it's not perfect, but it'll do. Okay, I need to go ahead and take a second to go ahead and clean up the damn desk that I just spilled shit on. 1 second, I'll be right back. Paper towel. There we go. Okay, so guys, here's how we progress for the night. So, we've got our test pad documentation. we've got our data documentation. So what we're going to do... oh, you did? Oh, rip. Okay, too late. Sorry, Agni K. It's cool. And again, it'll probably be fine once I fix the NTFS journal on my hard drive. So, we have our board here. And so what we're going to do now is we're going to go ahead and compare the test pad documentation that we have to the picture of the board and the physical board that we have here. And using all three of those, we'll get this figured out. Oh, I did? I didn't think that those made it up. My bad. Yep. Should be doing this in private. Boop. Yeah, one day I should actually go ahead and fill up the wiki with bullshit in the private section, and then actually go to that on stream and see what I can get you guys to believe. That would be fun. Test pads. It's not test pads. Is it teardown? Which, where did it go? No, this isn't our teardown stuff. Or, I mean, this is our teardown stuff, but where's my pictures? I actually don't remember. Oh. Why do we put those in the private section? Okay, give me a second, guys. I'm going to go ahead and... I don't need the private stuff right now. We've got what we need right here. I don't know what I'm fucking doing. Okay, cool. Let's go ahead and open up Reswitched. Let's go ahead and navigate to reswitch.tech. And what we're going to do is go ahead and look at the test pad documentation. Nope. So here's our test pads documentation, which is what we need, and we've also got our test pad images. I think the correct ones are online, but if not, we can go ahead and get those up at some point. So using this, our goal is going to be to go ahead and use the information that we've already collected to figure out what might be the supply rails. So, let's see. Was cluster E the one that was an issue? No. Oh, wait, yep, okay. What was cluster D? Because cluster D is the ideal. Beautiful, honey.
Stop.
We don't have cluster D on here, do we? I guess I never touched cluster D. Okay, I guess we're doing this with a multimeter then. Good job, Hedgeberg. Doing good. Okay, we're going to be poking this with the multimeter. Great. Good and great. So, yeah, let's go ahead and get that plugged in. I really need to free one of these batteries from the case, to be honest. Like, this is going to become more of a pain if I don't do it. Anybody know what the adhesive under one of these batteries is? I wonder if I could just get it out with some IPA. It's probably better not to bend it, though. Oh, well. Okay, let's go ahead and get this plugged in like so. So what we're going to do is boot up the processor without a clock. And so that means that nothing will execute, which is fine, because we just need to go ahead and see the PMIC get stuff turned on. Hopefully it won't burn out the processor. Is that the cat you're referring to as a little idiot? What'd she do?
She tipped over her food ball again.
Oh, God.
And there was just a lot of food in there.
Our cat is a lovable dork. Okay, so that's not going to help. So we're just going to go ahead and figure out what we can. So, right. Sorry, I'm talking to myself a little bit here to remember what I can in terms of what we're up to. I have a feeling, though, that judging by the placement of the EMI capacitor, that they've just got a saner power displacement system, and that this is going to be our point of interest. And if it isn't, that's awesome, because that means that we get the VDD rail as well as the stuff that's actually applied to the SoC. I've usually used gentle shear force precedent. Okay, so Scanlime, my thoughts would be that you can actually get it pulled off using specifically IPA, because IPA does have some fun with adhesives. It would probably go ahead and weaken the bonding strength enough that you could pull it off. but I'm unsure. Okay, let's go ahead and grab the multimeter. Where'd I put that? Right here. Okay, what we're going to have to do now is a couple of things that would definitely be considered stupid. So the first thing I'm going to do is I'm going to actually go ahead and apply the jump to get this turned on. So you can do that using these guys right here. So there's two test pads over here. Where are they? It's not those two. What are the two test pads I'm thinking of? Oh, there we go. Okay, so right here, there's these two guys, and if you just do that, boop. Okay, that should turn it on. And now we have to probe. But yeah, that's actually exactly where the power button connects to, so you can use that to figure out or substitute for your power button. No, I haven't actually replaced my probes. They're still shitty. I need to. I really, really need to. Okay, let's go ahead and take a look at DC volts. And if we're lucky, this should show us something along the lines of 1.2 volts. That's showing 0, but I don't think that's grounded. No, that doesn't make sense. Okay, so it's not that. So let's see. What do we got here? So let's do that then. So we're going to nest that guy right there. So let's get to poking. So what do we got? Zero millivolts. 0 millivolts. 0 millivolts. Yeah, okay. What does that mean? It means that this is not actually turned on. Great. So I need to go ahead and actually get this turned back on again. It doesn't actually think it's on when it needs to be. Yeah, there's no heat there. One sec. I'm going to go ahead and do the jumper again, and this time I'm going to actually jump it to ground instead of that pad right next to it. I thought that could be used, but I guess not. There we go. Pimp. Okay. Should be plenty. Doesn't get mad if all the daughter boards are missing. I mean, it does, but the thing is that the boot sequence isn't going because it's not clocked right now. Remember, Roto Penguin. I don't know. I don't know if that's... maybe. If I could grab something like that, that would be awesome. That'd be a smart thing to look at. Good idea. I will think about that. Nope. Jeez, you okay there, honey?
Some seeds went down the wrong hole.
Bad. Okay, one second. I have a feeling that I have this data somewhere, and I'm pretty sure I've already done this test. So there's no point in me repeating it. I'm pretty sure it's just sitting in... Where did we put it? Did we put it in the Switch RE folder? No, there's the underclock data. It's not in there. So where is it? Documents... Switch, RE, there we go. There we go. Okay, cool. Let's see, do we have pad D documented in here? I could have sworn we did. There we go. Why didn't I get the supply voltage on these? Okay, so 2 and 3 are supplies of some kind. So what this means is that what's up on Switch Brew is out of date. Not on Switch Brew, on Reswitched. So you've got 2 and 3, and I don't remember what the voltages on this were, and I guess I chose not to measure them? That doesn't feel right. Yeah, and those two were the speakers. So then, what on earth are these? Only one way to find out, I guess. Let's go ahead and solder to them and take a look at what we see. No, Ogni K, I'm really not actually sure that the switch is on. I have no idea. We might want to go ahead and attach to those and then come back to this. Oh, see you, Triggered Tux. Have a good one. Let's go ahead and... Okay, if we're going to solder onto these... Don't want to be dealing with this kind of shit right now, but I guess what we got to do. These are the two most exposed power rails as far as I can tell, so these are the most likely locations. Like, the widest power rails are going to be the ones that draw the most current, so if I had to guess, I'm going to say it's this one. I doubt it's number 3 over here. So I'm going to guess that it's this. So let's go ahead and just take a look at number 2, see what we can figure out. That's probably the best way to go about this. I could just try to poke it with the oscilloscope and see what I could figure out. I don't know. First, before anything else, let's go ahead and see if we can't get the battery out of here. I think that'll be kind of fun. See if we can't do it with some isopropyl. The question is how we're going to soak isopropyl in around the edges. Probably just soak up a cotton swab and then just like dab it in around the corner, see what we can get. After a while of soaking in, it'll either work or it won't. So worth some fun. See what happens.
Yes.
What?
Huh?
What?
Oh, the cat just moved, didn't it? You weren't supposed to hear that. You have headphones on.
I can hear a lot of things depending on whether or not I'm listening to stuff. I need to be listening to music. I forgot about that. So if we're lucky, this will give us really cool, good results, and the battery will come right out. And if we're not, it won't do anything. So we'll see what happens. I do have this sponge totally soaked with IPA, so that's probably a good sign. Okay, let's see. Any luck? Nothing yet. We gotta wait. I think. Maybe, actually. Maybe it did work a little bit. We'll see. We'll see in a little bit. I'm also going to want to... Here, let's go ahead and grab some more IPA, and I'm going to dab it underneath the battery cable. Now, you guys should be seeing this a little bit better, shouldn't you? There we go. Oop, Jesus Christ. 1 second. I basically just spilled IPA on my desk. Let me soak some in there, see if we can't get some gravitational stuff going. And then I am going to have to clean this up, and my whole apartment is going to smell like alcohol. God damn it. Be right back. Okay, I guess there is no trash bag.
What?
There is no trash bag.
What?
There is no trash bag.
Yeah, I just took the trash out. You're welcome.
Thank you. I appreciate you. IPA all over my oscilloscope and on my multimeter. Doing great. Really, really great. I'm kind of a ding-dong. Did you guys like my song? Probably the best music you've ever heard. Am I right? Probably not. There we go. Okay, that's a good...
You're beautiful, and I love you.
Thank you, honey. Okay, let's see if this got the job done. Odds are no, I'm guessing, but we'll see. Oh, maybe. Didn't go all the way. Oh, it definitely got some effect. Oh, oh. Come on. Come on. Yeah, there we go. Yeah, that definitely had an effect. Oh, geez, yeah, I wouldn't have gotten this without the isopropyl, I don't think. I definitely wouldn't have without the isopropyl. Like, it's all soggy and goopy down here. Interesting. Okay, well, good to note. So yeah, if you guys want to get the battery out of your Switch, soak some isopropyl around the edges, wait a few moments, and then get to it with some tweezers. And yes, it is glued in. There's this nasty, nasty sticky. It's really sticky. Like, this stuff needs a lot of force to get out. Ooh, oh god, yeah. Okay, so I started drying up the IPA on the battery stick stuff with some paper towel, and the paper towel didn't want to come off. This is really, really heavy bonding adhesive. Oh, geez. Yeah, so if you guys want to get the battery out, that's how. You gotta soak these surroundings in IPA. In fact, I'm willing to bet that's probably what they would actually do at the factory, too. So the trick here was just some IPA, 91% if I recall correctly, and Jesus, this is really, really nasty epoxy, or not epoxy, adhesive. This is, oh jeez, oh, this is upsettingly sticky. Okay, I don't want to touch that anymore. If I were to flip that over, it would get stuck to my desk, no question. Well, that's a little discovery. Neat, though. So we just got this. I think that might be the first time the Switch battery has been removed outside of Nintendo. Cool. I don't know, it's fun messing with... what am I talking about? I'm willing to bet somebody from Derek's team has already done that. I'm not exactly trailblazing here. Yeah, so you can see a little bit of an indent where we did the scratching, but, like, the rest of this just came clean off. Yeah, no, this is a pouch battery. This is a pouch LiPo battery, and it's definitely a nice one as well. Like, I think this one's 3100 milliamp hours, 4310 milliamp hours, 4310 milliamp hours, and it's really thin. Like, you can see how thin it is right here, compared to my fingernail, and the area is about the size of my palm. It's a very, very high density battery. No, I didn't. I didn't take the battery out. The battery's still in that case, Normat. Okay. Neat. Now, you know what? Okay, give me a second. I'm gonna... Oh, that's true, they have. How did they get it out? Did they just apply force? Forget that I fix it always does this stuff. Man, I'm never the first at anything. One day I will have the right to be first. Okay, so I'm doing a dumb hack to prevent this from getting stuck to my desk, and I am just covering it in paper towel. Stupid solution. But it gets the job done, and this way I won't get it stuck to my desk if I flip it over by mistake. This stuff is really, really sticky. This stuff is really, really sticky. Ugh. Bad to touch. Okay, let's go ahead and get everything plugged in here. So, I mean, so look, I actually saw somebody mention something about it the other day on Temp, like that I was one of the devs of B9S. B9S/SIGHEX is really more SireZem's baby. I was part of the team that was working on it, but the end solution was SireZem and Miri's work. To be totally honest, like, we all worked together on it, and so I wound up on as a name on the release, but it was their work. It was really their work in the end that got it there. So I count that as their release. Okay. I don't want to steal credit from those guys because those guys are amazing. And if anybody deserves credit for it, it's them. I saw somebody saying that I was, quote, one of the main devs of B9S, and that was just blatantly false. I'm not a good dev. If anybody says I'm the dev of anything, then they're wrong. That is true. I am the first person to name myself Hedgeberg on the internet. That's something. That ain't nothing. Okay, cool. So that's freed. We've got the battery freed, so it's going to make this a whole lot easier. So we're going to want to go ahead and probably solder on there, solder on there. I'm not going to mess with mag wire because mag wire is a pain in the ass to strip, and I have this pretty decent wire here already. So what we're just going to do is we're going to use some of this fine AUG wire, solder it to those contacts with a pretty, like one of the wider soldering iron tips to get some good thermal conductivity. And we'll just use that, and then I will grab that with the... so we'll solder, I guess, probably there, there, and there, and then we'll look at this and see what we can figure out. Yeah, if they managed to pull that... I would not have felt comfortable doing that, personally, with a lot of force. Like, that took a lot of force as it was, and that was with the IPA. If they did it without the IPA, I would not have felt comfortable. I would have shattered the screen first, I'm pretty sure. I don't know. I don't know if that would have been the smartest way to go about it, at least. If I were you, I would definitely get some IPA in there. Anyway, guys, I will be right back. I would probably do IPA wiggle, IPA wiggle, IPA wiggle, just to slowly loosen it. Like, honestly, I think I used more force there than I needed to. If you used some more IPA and some more wiggling, you could probably get it even better. Real quick, by the way, IPA doesn't dissolve adhesives. The reason that it works is because of the fact that it loosens the bonds there. But once the IPA dissolves, once the IPA evaporates, it actually goes straight back to being sticky again, usually, which is kind of neat. Anyway, I'm going to go get some water in this sponge, and then we're going to go ahead and solder. So I'll be right back. Straighten that out.
Why'd you leave the mic on for this?
Huh?
Why'd you leave the mic on for this?
Huh?
Why'd you leave the mic on for this?
I don't know. I've been leaving the mic on more whenever I get up.
Okay. Okay.
Rude.
What a big fart you did.
Rude. So rude. I need another sponge. This sponge is getting really old and kind of nasty. Okay, let's see what we can do. Okay. Oh no, I have brass wool, but the issue is that one of the joints in the base of the brass wool, you can actually see it right here. The rubber foot in the brass wool has actually come out. I should probably just cover that with electrical tape. That would be a good fucking idea, wouldn't it? Sometimes I do the dumbest shit. I almost slashed myself with this razor just now, too. I am a fucking disaster. There we go. It depends on how tinned you want it. If you want a loose tin, then yeah, it's better to not use a sponge. If you want a tighter, so if you want a tighter tin, then yeah. I don't know. I think Derek might have actually done it. I'm not totally sure. And if Derek took pictures, those are probably higher quality, but I don't think he's posted them anywhere. If he posts stuff, usually it's to his Flickr. And he has access to a much higher quality. He has access to a much higher quality scanner, so I'd actually keep an eye out for that at some point. Because if Derek uploads some ever, then they're going to be real nice compared to mine. Okay, heat up the soldering iron. Where's my flux pen? Probably dab a little bit of flux onto each of those pads. Let's see. Oh, right, music. I keep forgetting to actually put on some music. Stupid. No, guys, don't think of what I'm the first. I don't want people blowing up my ego. That's not helpful. I was mostly just joking. Okay, let me go ahead and get some music going. Hey, Roto Penguin, don't be nasty. Okay, there we go. Got some music.
I'm sleepy.
Go take a nap then.
Don't tell me what to do.
Okay, honey. Okay, let's go. Okay, gotta tend this a little bit more. There we go. A little bit more. I need to really restock my my workspace. I need some new. I need new IPA. I need some more solder of other sizes. There's a lot of stuff that I need. Thank you, honey. I love you.
Love you.
So this is only 375 right now, and this is definitely the lower watt iron. Need to step that up. Setting up to 420 degrees A. Nice.
That's a weird number.
Nice. Cool. Good enough. Light up a fat rosin core one. Christ. All of the worst. You will see no such scandalous things, because I am straight edge. God, no. What? So the other day, what was it that happened that made you want to be straight edge?
I got really drunk.
Oh, right. You got super drunk, and then insisted that you weren't drunk, and then insisted that you were going to be straight edge, and then tried to listen to straight edge music.
I have no hate for people who are, but...
No, of course not, but it was pretty silly. You were really drunk. Was that the first time you were on Four Loko?
I think so. I was also really mad at you because you didn't believe me about becoming straight edge.
Yes. God. That was a hell of a weird night. Oh no, it absolutely sounds like fan bait. It sounds like something that, if anything, it would have to be drunk hacking, but drunk hacking is a recipe for disaster. Did she let out any noises?
Yeah, they said they heard her. Say hello, Jellybean. Come on. You talk all the time. And now you're silent. You have stage fright. Yeah.
Or cat has stage fright. Oh well. Okay, let me get this wire strips. Let's get it trimmed down to about there. Yeah. Okay, and on the other side, we're gonna. And the reason I'm using such high gauge wire is because the fact that this is a lot easier to interface with the logic analyzer. If I were doing more pads, then I wouldn't be using this size wire. But this is what we're going to be using for right now. So give me a second here. I'm going to go ahead and tin this wire. So let's just come over here, brass tin.
What's Mama doing? What's Mama doing?
I actually feel like this iron might be getting worse performance over time, which is weird because the tips aren't oxidizing. Gotta wonder if there's something going on there. Maybe I need to look at the heating element. I could probably modify this to be higher temperature, actually. That might be a good idea. I'd have to figure out how to recalibrate the PID loop. Boop, boop.
Do you like being tall?
Okay. Careful.
You okay?
Perfect. Okay, that's one. Those diff pair. Yeah. They're USB 3, as far as we can tell. But there is also a PCI Express bus routed on here somewhere. But it seems like these are pretty definitely USB 3, considering the proximity to the USB-C adapter and also the fact that there's a USB 3 multiplexing hub right here. No, RotoPenguin, they're definitely not HDMI because of the fact that Switch doesn't have an HDMI output port. It does DisplayPort over USB-C, and then the dock transitions DisplayPort to HDMI. Okay, we need to go ahead and get that one, and then we'll step up to the temperature again to 420 blaze it degrees. Okay, honey, I don't think the cat wants to be held anymore.
Good girl. You let me hold you so long. You're getting so good at being held, yeah.
I think she might just be resigned to it at this point, honey. I don't think it's that she's getting good at it. I think she's just accepts it.
Maybe, but that's good enough for me. You want some tuna? Yeah, you always want to.
I mean, that's part of, yeah, DisplayPort's an open standard, and it's also easier to implement, if I recall correctly. It's one of the reasons you don't see HDMI as frequently on open source projects. Oh, that's really cute. Honey, Scanline points out it was much easier to... Honey, you'll like this. Scanline points out that she found it much easier to hold Tuco when she found out that they both shared a love of watching birds.
Aww. Jellybean likes it, or is more comfortable with being held when you rock her back and forth like a baby. That's why I do the little bounce hold. It's the exact same I do with babies. She like doesn't fidget as much.
Careful.
Sometimes if I have to go out though, I'll put on a video of like a sped up video of a bird feeder for her to watch. She likes it.
She does like looking at videos of birds. There's just not a lot of birds in Pittsburgh is the issue.
Nah, at least not around us. There was a turkey.
There was a goddamn turkey at one point.
There was a wild ass turkey.
in
I
the
hope
middle
that
of
turkey's
Pittsburgh.
okay.
I wonder if somebody brought it into Pittsburgh to like kill it for dinner and it escaped.
I don't know.
Because it wasn't on was it on Thanksgiving?
No, it was not. It was over the summer, babe.
Right. It was really weird. There we go.
Oh, I love crows. I love crows and ravens.
Okay, that's getting hot. That's getting hot for my finger to touch.
I love a lot of birds.
Probably stop touching it.
I also love pigeons. Pigeons get a bad rap, but they're good birds.
Fat.
Fat.
Did you know that pigeons were brought to the U.S. and intended as a food bird?
Yep.
I didn't know that until the other day.
Thought I told you that. We brought pigeons here, yeah. One time, we stopped our car at a stoplight and we watched a pigeon walk all the way across the intersection.
It was incredible.
In the crosswalk. It was very cute.
Okay, this is getting to be a problem.
Now I always look for him when we come back.
Sometimes he's there.
Is someone cooing? You know what? I was rubbing the glass of milk. I'm very sorry. That was probably me.
Yeah, okay, this is not hot enough right now. I'm going to need to make it hotter in a second. I'm also going to need to go ahead and clean that up.
That's a good point. Pigeons have a hard life, and they deserve more respect. Alright, I'm gonna go eat my biscotti.
You still have that?
Yeah, I forgot I had it.
The biscotti I stole from work?
The good thing about a biscotti is you can never tell when it's fucking stale.
Yeah, I need to clean that up. That's nasty. Okay, give me a second here.
That was a good joke.
It's a little gross.
Fuck you.
Yeah, no, there is some worry about lifting the pad. Again, though, this is... I'm not super worried with this. The issue isn't the size of the wire, it's the fact that this iron is being an asshole. Now Stuck Pixels made me all sad about my iron. It's just not a high enough temperature right now. That's better. Yeah, let me wake this up real quick. Come on. Well, that's not good. That might have just made it worse. Come on. Yeah, it's not good. Some of the old wick got stuck. Okay, that's fine, actually. Okay, give me a second to cut the wick real quick. Add some flux. Yeah. It's something I've been trying to work on, Scanlime. Give me a second here. Tin my iron. Yeah, there's way too much solder on that pad right now. I must have dropped way too much on there when I was prepping the pad initially. No. Okay. It's getting a little better. The main thing I'm worried about is that little capacitor right there. These capacitors are connected to this, so it's not an issue. But, oh, right, now that Moo's up, I can actually plug in the hot glue gun. Give me a sec. We're going to check to see if that is actually connected. I don't think that's actually bridged now. Yeah. Yeah, it's not bridged. Also, it is actually connected there. Yep. Okay, cool. So that's not bridged. Cool. That's as good as we're going to get it. I'm not going to mess with this right now. Yep. Yeah, exactly. I've been doing more and more IPA, hot glue stuff. I actually use it a lot at work. Scanlon, I actually impressed my boss with that trick because he didn't know that. He's like, I can't take credit for this, but he seems to insist that it was pretty neat. Where did I put that wire that I was just using a second? There we go. It's right here. Okay, cool. Okay, hot glue gun's heating up, so I'll glob that on both of those in just a second. Oh, but yeah, Scanlan, one of the issues with the plane is that this iron just doesn't get enough power, it's seeming like. I'm finally starting to wise up to the fact that my iron probably doesn't get enough power. Stuck Pixel made me self-conscious about it the other day, and now it's, can't not notice it, and now I need to go ahead and think about getting a better one. So, like, I can't solder to the ground plane because I can't get it hot enough. Even when I put it on the preheat plate, which is frustrating. Okay, let's go ahead and get this guy on. Pretty sure the answer is just my iron. Come on, don't... whatever. So those are actually all part of the same connection, so it should be fine. Or if it doesn't, it won't turn on and we'll know. Okay. It's definitely better than 25 watts. I don't know what the issue is. It might just be the tips, honestly. It might just be at the, that's the power rail we're looking at glitching. There is actually the possibility, though, that there is, that the reset line is glitchable, or that the clock line is glitchable, as we're discovering. It's actually looking like it might be slow enough that the ARM7 TDMI might have a PLL multiplier of 1. So it might actually be possible, with some clever tricks, to glitch it. So, either of those might be more effective. But yeah, right now I'm just trying to figure out what's what before we get to that point. It's looking like we're going to be able to get a good glitch by removing this guy. So... Yeah. I mean, it takes like 500 milliseconds for it to do simple AES verification. And that's with a hardware security module in there. So, IDK. Okay. Here's our wire. Let's go ahead and tin this real quick. But yeah, I'm not sure on clock glitching stuff, and I can't test that until I have an actual NAND adapter for this. So before we can even make that test effective, I need to go ahead and get my handle on one of those. So I've been talking to StuckPixel and Dakin about getting those. Because StuckPixel has one for me that he wanted to ship me, and then it also looks like I might need to be able to For the clock glitching option, we'd actually have to look at instructions, or we might have to look at modifying the BCT. Like, see, that one was fine. I wonder what the difference is. Anyway, I got some nasty shorts there. Cool. Better. Cool. Should be fine. Yeah, the rest of that's not shorted. Okay, cool. We're good. Let's go ahead and get to it. So we just need to go ahead and judge whether which of these rails is which. So let me just goop on some hot glue real quick. Okay. Gun is good and hot. Let's go ahead and yep, get out the initial blob. There we go. Careful. But yeah, I'm going to use the logic analyzer oscilloscope so you guys can see what's going on here. Give me a sec. There we go. Cool. Cool. Huh. Yeah, that makes a lot of sense, Scanline. Parasitic inductance can make that kind of pulsing a major issue. Okay, this should just, there we go. Okay, there we go. Good enough. But yeah, no, the main reason I didn't want to deal with magwire is because it's just easier to attach to the... it's me being lazy. I just didn't want to deal with attaching it to the... for setting this up. Okay, let's go ahead and pull up the logic analyzer. Let's go ahead and move that over. Don't need 2, we just need 0 and 1. And then let's go ahead and grab this. Let's go ahead and grab the logic analyzer. I need one more clip. There we go. Okay, 0, 1. Oh, that's a ground. There we go. Ground. Pad 2. Pad 3 is where? There we go. Okay, let's take a quick look. Oh. There we go. Wasn't getting so good of a connection. Okay, there we go. Hey, Hedge, I'm going to go to bed. Good night. Yep. Have a good night, Valiant Storms. Thank you for tuning in. Where to put the battery? There we go. Okay. One of those came unconnected. That's okay. Oh. Oh, shoot. 1 second. We actually are going to need to rig this up in the helping hands because the other side of the board isn't really accessible. Give me a second here. Let's grab the helping hands from down here. Okay. I love getting these things out. It looks, honestly, the way that these arms look kind of makes me feel like they're a little bit alien, which is stupid, but fun. Okay. So I'm going to attach. There we go. Hopefully you guys are seeing all of this. Yep. Okay, cool. Okay, there's that. So let's do that. There's that. We're also going to need to be able to mount the battery with the helping hands, I think. So good thing I've got 2 of them free. And we'll see if we need the clock. I think there's a good chance that we do. It's looking like the clock might also be used for the MCU or something. And if that's the case, then we definitely need it. Oh, actually, I need to move this over to here, it looks like. Give me a sec. That's what, the ground? No, that's just... one. This test clip really does not want to stay on. I should probably get another one. Oh well. Okay. This is a hacked-ass solution. But it gets the job done. There we go. Okay. I really like the battery connector on the Switch, by the way. I know I've said stuff like that a lot about the Switch in general, but I really do. Like, it prevents shorts pretty effectively. Okay, just need to keep this from falling. Good enough. Okay, let's go ahead. Start. Where are my tweezers? Aim toxicology. There we go. Nothing. Either the battery's empty or this just is not having a good time. Oh, weird, the clock ports. Oh, geez. Something shorted in there, that's not good. Something was starting to heat up. That's bad. Where's the heat happening? We didn't burn this out. This was our go-to target. How much RAM does that system? I mean, it throws stuff out. It throws a lot of data out. It waits until the trigger occurs before recording. I think there's a good chance I just killed this thing. Okay. No, don't start whelping. We're not sure yet. Let's make sure we know what we're seeing before we actually go ahead and say whelp. It could be that it's trying to clock and that I'm not providing a clock and it's not playing nice with that because of that. Like, if I provide a clock, it might actually end up being fine. There's plenty of easy ways to check to see if it's still live. One of which is removing these wires I attached and testing. We'll see. I really don't think I killed it, honestly. Or if I did, then rip switch. We'll figure out what's next. Like, it could be that it's trying to turn on the SoC and it can't because of the fact that there's no clock and it's not having a good time. Okay, I need a better test hook than this. This one's just shitty. There's one right there. I should throw out that test hook instead of just putting it over there and using it again later in life, but whatever. Let's see. Okay, let's give this another shot. So before even pressing any of the power buttons, I'm just going to plug in the battery and see if it heats up in the same way. And if it doesn't, then I don't think it's dead. I think it's just an issue of clocking. And we'll just have to provide the clock. We'll see. Give me a sec here. Yeah, no, it's not heating up at all. Yeah, I think it's fine. Let's just go ahead and see what happens if I clock it. Okay. Do it, I think I would. Okay, let's hope I didn't screw this up. Fingers crossed. Okay, chip whisperer. Let's get you plugged in. You know what I might do? I might actually remove the power button from the case and hook that up as well. Considering we've already removed the battery, we might as well, and then it's safer. I'm trying to poke around with tweezers. There's a plenty good way now that we have this mounted like such to debug this, which is just to go ahead and plug in the eMMC board again. So if we need to, we can just remove those traces, remove the solder. Or remove the hot glue, remove the solder, see what we can do. So there's plenty of options. Or worst comes to worst, I do still have my main switch, which I haven't been using much. There we go. Okay. That should be good. Let's go and get the chip whisperer open. Chip whisperer cap. Scope. Oh. I'll show you guys the chip whispers over there. Bum. For you to choose not who we should be, because we're not party. 3 megahertz. There we go, gets rid of the red lights. We should be good. Make sure that it's piping it out through high-speed I/O out. Clock gen, good to go. Okay, cool. Damn it, no. Okay, yeah, all my nodes are connected as expected. Okay, where's the switch case? We're going to take a quick look at removing the power button. How are you held in there? Oh, this ribbon cable is pretty stretchy, actually. Nice. All we need. I mean, maybe it comes out. Nah, it doesn't need to. I can just... Come on. Let's unplug the battery while we do this, just to be safe. There we go. Click. Cool. Not quite far enough in. Sooner or later, this will all be automated, but right now... Yeah, no kidding, I agree, smart person. Oh, not plugged in. Hot, hot, hot. Bad. Yeah, okay, something in there shorted. Okay, that's fun. Okay, let's go ahead and remove our shit, and make sure we can just get this thing live again before anything else. Man, I hope I didn't kill anything. I was Cleopatra. I was young and an actress when you knelt by my mattress and asked for my hand. But I was sad. You asked it with my blade in a oh, damn it. My father in a casket. I had no plans. Oh. Look at that. The footprint and a stain on the carpet and hardened like my heart did when you left town. That one's just a minute. Pretty sure it is, yeah. Also, hi, Bonnie. I think you're probably new here. Correct me if I'm wrong. If so, welcome. Glad to have you. Late for that, late for the love of my life. And when I die alone, when I die alone, when I die I'll be on time. I forgot to take my Adderall. Whoops. Yeah, appreciated. Again, Scanlime sends me a lot of traffic, and she really doesn't need to, and it's appreciated. She's here right now, actually, I think. Okay, let's see. Hopefully I can just... There we go. That's one. That's two. Okay, it's debugging time. Let's figure out what's going wrong. So I'm going to go ahead and pull the wires, and we'll go in and figure out where the short is. Yeah, Pinbite, those exist. It's called a wire bonder, and they're crazy expensive. I would love a wire bonder for this kind of stuff. But wire bonders are mostly for packaging stuff in general. Okay, so let's go ahead and do this. Iron on. Let's go ahead and pull these, and we'll go in and we will probably spend a little bit of time wicking up all of the solder in there. Die alone, die, I'll be on time. I don't know what COB means in this context. Also, what is the... Okay. I'd just like to point out, my brain has been farting hardcore. What's the term when you use a bunch of letters to represent something? Not words, obviously. I mean, like you take the first letter of each word. I've been trying to remember it, what the word for that is, and it's driving me nuts. Because I know that I've been referring to it because like I'm bad at abbreviations. So I was talking to Naywert yesterday actually, and he used one that I didn't recognize, and I had to be like, abbreviations confuse me in general because I couldn't remember the damn word. Acronym. Damn it! Oh, I'm an idiot. I hate that. I hate when you can't remember the word for something simple, like a word that you've known all your life. Okay, let's go ahead and get this. No, not a mnemonic device. It's an acronym. I'm awful at acronyms. And also, apparently, at being a human being and speaking the English language. I actually think I see where the short is just from looking at this above. There's a few places it could be, and honestly, it might just be better for us to remove a bunch of these capacitors anyway, to try and rescue this thing. Although, hopefully, I haven't already killed the PMIC. Because I think it was actually the PMIC that was getting hot, because that's right under the clock ports. I'll show you guys. So, where's the stick buys? There we go. Let's go ahead and get the microscope up. I actually don't know if this can really be called a microscope, honestly, because it's not exactly microscopic. It's lensing, but it's not very lensing. Like, there's a single lens. Okay, so let's take a look. Oh, so sorry, I'm just getting the board in place. Come on. Wine is not an emulator. Okay, so I think the issue's going to be right here, but I could tell, like, here or here, but I could tell that the PMIC was getting hot, because that's where the PMIC is, and the glue for the, where I soldered the clock adapter was getting hot, and the glue where the clock adapter is right there. So right above the PMIC. So I guess it was getting hot enough to start to melt the glue, so there's a good chance the PMIC is dead, and I hope that's not the case. Because if it is, then I'm going to need to start working on a different switch. But such is life. This thing was already dead, so it's not like we lost anything. I like both of those. None of this Unix and News Not Usable. Those are both really good. I actually haven't heard either of those before. I heard a different one. Okay, any hot glue left? Doesn't look like it. Okay, let's just go ahead and sponge all these up and make sure that the switch is still live. And then I'll figure out a better way to get my bullshit done. Feels stupid. Okay, let's see. Okay, got my iron. Iron is hot. Actually, don't want it to be hot right now because I probably want to go ahead and switch tips. Nah, not yet. We'll do that in a second. Let's go ahead and tin. So we're going to want the temperature up higher for this. Okay, raise the temperature. I'm going to want to go and get some more coffee in a second. Good news is, even though I've made some dumb mistakes already, the stream goes for a while longer. I'm actually surprised I'm holding up this well right now on this stream without Adderall. Usually, if I forget to take Adderall before a stream, it's extremely noticeable, but today I'm actually handling it okay. Surprising. guess I'm just particularly focused at the moment. There we go. For a moment there, my brain just thought of saying to the wick, "Oh yeah, baby, eat it up," and I feel so gross right now, and I'm so sorry that I had to tell all of you that. I just want to offer you all the sincerest apologies I can. Yeah, Moo just sneezed in the background. Yeah, it does. It's an EMI capacitor. We were talking about that earlier in XDev. That is where what we're hopefully going to be able to remove and tap not man in the middle, but to make the 1.2 volt line resistive, ideally. Oh, I couldn't hear anything. Oh, yep, there was our short. Found it. I was wrong. That was not an okay short to have. Hedgeberg for Idiot of the Year. Let's go ahead and take a quick zoom in and take a look at what actually we bridged there. Oh, by the way, Scanlime, could you think of the reason why there would be, if you're here, could you think of a reason why there would be... Oh, God. Scanlime, stop. Also, yeah, Moo prefers they/them pronouns. And also, Scanlime, Jesus. No. Oh, you guys are the worst. It's a good thing I have this stream rated as being for mature audiences. Specifically because of stuff like this. Scanlime, I don't know if you can I'd just like to point out, I've seen you retweet stuff, wait, Moo, you knew this. I've shown you things that Scanlime retweeted about people hacking dildos. None of this is surprising. Okay, yeah, so we shorted just about the fuck out of everything. I am not proud here. Where are my pointier tweezers? I looked at these from above and thought they were all fine, and the reality is that none of it was fine. Where are my tweezers? God damn it. Okay, we're using my fat tweezers. So you got this guy, which was shorted, and this guy, which was shorted. So this is off of there, and this is not connected to there, and whatever these were that I got connected, I did a bad thing. And then also these were connected to ground. I really fucked this right up. Okay, I did also tweet about a dildo at one point, but that's because of the fact that it was funny to me. It was funny to me finding that. I mean, I'm not saying it's a bad thing to tweet dildos. I'm just saying I think hackers are perverts. I think there's an overlap in that community that may be more significant than most communities. I'm not saying I'm exempt. I don't believe the magic smoke got out. I'm pretty sure it's still fine. Yep. That's a little better. Where the hell did my tweezers go, though? Okay, so now we know what the issue was. I'm gonna go grab some. Coffee, and then we're gonna rig this up and try to boot again and see if it's live or if this thing's permanently dead now that we've actually gone ahead and cleaned it up. It should be fine now, I think. But, yeah. Hopeful. I really hope I didn't kill this. If I did, though, it won't be the first time I killed something on stream. I've killed plenty of Nintendo consoles. This won't be the first, and it won't be the last. Is the point. So yeah, give me 1 second. I'll grab some coffee, and we will go ahead and flip this over and give it another shot. I'll see you guys in just a second. Smart person. She wasn't saying that we should figure it out. It's that it is actually the case. Like, oh, no, no. Yeah, it would be safer to use a current limited power supply in that case, but, yeah, no, that actually wouldn't be that difficult. I have 2 power supplies. One of them isn't good, but one of them is. I got one of them from a local lab. I got... Here, I can show you guys the, So I've got 2, one of which is really bad, but the other one I have is a BK Precision 1550, which is this wonky-looking thing. Yeah, there we go. It's got like a trackpad click... It's got like an Apple iPod click wheel. But, yeah. Yeah, I had forgotten about this. I've got it sitting over there. I didn't forget about it. I had forgotten that not everybody realized that I had this. It's fine. And yeah, Scanlime, I can do that, and it'll probably take about 4.2 volts if the previous Nintendo generation of consoles was anything to judge it by. Yeah, I just thought it was weird that it had that trackpad, or not the scroll wheel on it. Anyway, I'll be right back. I'm gonna go grab some coffee, and we'll get right back to it. There we go. I'm back. Scanlime, yeah, but it doesn't like to communicate. It doesn't like to communicate, or it doesn't like to power up because of the fact that it doesn't have that weird middle pulsing terminal. So it's like it requires a specific voltage if it detects that it's hooked up to a lab supply. It's weird. But yeah. Yeah, it does. There's a battery sensing circuit, and at least on the last generation, as well as this one. So in the last generation of Nintendo consoles, and this one, I mean, I know that there is because I've seen it, but yeah, there's a sensing pin for determining if the battery is in place. The battery just issues a series of pulses. I don't know, it might be thermal. Yeah, I mean, it's actually... I mean, here, real quick, I can show you. The battery pads are actually, like, clearly labeled for us. It's just, the ground terminals are pretty clearly connected directly to it. Wait, let's see real quick. Where is it? There we go. No, so here we go. So here's our battery ground. Battery VDD is accessible on the other... Yeah, it's accessible right on the other side back here.